We're going to just quickly look at how we can apply what we've learned about parallel and perpendicular lines and their gradients to some questions. So the first one is determine whether line segments A, B, and CD are parallel, perpendicular, or neither in each of the following cases. So in case 1, point A is -1 and -3. Point B is 1 and -3. Wait, no. Look at the wrong thing here. Right, point B is 2 and 1. And point C is 4 and -1. And D is 7 and 3. Right, and so the question is, are A, B, and C, D parallel? So we'd need to find the gradients. So the gradient of AB would be 1 minus -3 over 2 minus -1. So 1 minus -3 is 4, and 2 minus -1 is 3, and that's about as simplified as that gets. And then the gradient of CD is going to be 3 minus -1 over 7 minus 4, and that's 4 over 3. So because MAB, the gradient of AB, is equal to MCD, the gradient of CD, therefore they are parallel. Okay, right, and then next one, we've got A at 1 and -3 now, so we're going to move that up. So that's going to be at 1 and -3, so A is now over here, and B is in the same place, C is in the same place, and D is in the same place. Okay, and we need to figure out whether AB and CD have any kind of relationship. So MCD we've already worked out to be 4/3. MAB is 1 minus -3 over 2 minus 1, which is 4 over 1, which is just 4. And so there's no relationship there. 4 is not the negated reciprocal of 4 over 3. It's not equal to 4 over 3. So there's no relationship there. It's neither parallel. They're neither parallel nor perpendicular. Then the last one, we've got A in the same position, B in the same position. C is changing position. So C is no longer at 4 and -1. It's now at -3 and 1. And D is also changing position. D is now at 1 and 0. Right? And so you could plow ahead and figure out the gradient of this line and the gradient of this line. But what you will observe is that the y coordinates of these two are the same. So this is a horizontal line, and the x coordinates of this guy are the same. So this is a vertical line. And so, I mean, one would argue that they're not perpendicular because they don't meet. So that's an interesting question. But if you did have to extend this line this way, for example, then they would definitely meet at 90 degrees. So my venture would be that, I'd rather say that they're perpendicular. Right? But if you had worked out the gradient, so if you worked out... Wait, also... Oh, okay. So I have misread. So I forgot what the instructions were. So the gradient of... Yeah, okay, sorry. I went off on a tangent there. So 3, 2, 1, I'm erasing. Okay, so A is in the same position, B is also in the same position, 2 and 1. C is at minus 3 and 1, so over there. And D is at 1 and 0. Right, so on the x-axis. And remember that we're asked whether A, B, and C, D are perpendicular. So we need to figure out the gradient of this line segment over here and that line segment over there. And we did work out what the gradient of AB is. I think that was 4. Right, and so we need to work out the gradient of CD. So let's say y coordinate of C minus y coordinate of D over x coordinate of C minus x coordinate of D. And that would be 1 over minus 4, which is negative a quarter. And those are indeed negated reciprocals of each other. Or you could say, well, 4 times minus a quarter is equal to minus 1. So they would be perpendicular. Someone might argue that they don't actually meet. So how can we say they're perpendicular? And that's a good point. But I would just go with the flow and say they are perpendicular. Just imagine that you extended the line segment. I don't know. Right. Let's look at another question. You're told that you have these 4 points, A, B, and C. You don't have the full coordinates. You just know the y coordinate. And you have D. And you're asked to calculate the value of x in each case if AB is parallel to CD. So just remember what that symbol means. So useful to plot. A is at 3 and 4. B is at minus 1 and 7. So somewhere up there. Right? And then C, we don't know really where it's what it's about. D has coordinates 1 and 8. Okay, I need to redraw this. Right, and D is 1 and 8. Okay, and we're told in the first instance that AB is parallel to CD. And all we know about C is that its y coordinate is negative 1. So C could be anywhere along this line, right? But we're looking for C such that AB and CD will be parallel. So that suggests that CD will look like that, and C would be somewhere here, right? So we need to figure out what that x coordinate is. And we know that parallel lines have equal gradients. So if we know what the gradient of AB is, then we know what the gradient of CD is. The gradient of AB would be 7 minus 4 over minus 1 minus 3, which is 3 over minus 4, which is minus 3/4. So the gradient of CD will also then be negative 3/4 because they're parallel, right? And so then 8 minus minus 1, right? The difference in C and D's y coordinates over 1 minus x needs to give me minus 3/4. So I'm going to get everything over a denominator, common denominator of 4 times 1 minus x. And so up here, 8 minus minus 1 is 9. We're going to need to times that by 4, right? Because we've introduced this 4 to the denominator. And then on this side, I'm going to say minus 3 times 1 minus x. And now I can just ignore my denominators since they're the same. So 9 times 4 is 36. And on the right, I'd have minus 3 times 1 and minus 3 times minus x. So that'll be plus 3x. And so 39 is equal to 3x. If I add 3 on both sides, divide by 3, x will be equal to 39 over 3, which is 13. And that kind of makes visual sense. It agrees with my visual, right? And then the second scenario is where AB is perpendicular to CD. right? So I've just plotted our points again, and again, all we know is that C could be anywhere along this line, right? Because y is equal to -1 on this line. So we're looking for C such that AB and CD are perpendicular, right? They meet at 90 degrees. So this is the C that we're looking for, right? We know that its y coordinate is -1, but we don't know what its x coordinate is. So we know that the gradient of AB is -3/4. So that means that the gradient of CD will be the negated reciprocal of that. So positive 4/3 will be its gradient, meaning that, and that's because they're perpendicular. So 8 minus -1 over 1 minus x needs to give me 4/3. So I'm going to make a common denominator of 3 times 1 minus x this time. And so at the top I'm going to have 9 times 3, right? And on this side I'll have 4 times 1 minus x. And now I can ignore my denominators, so that would be 27 is equal to, let's distribute the 4, so 4 minus 4x, and then I'd subtract 4 on both sides, so that would be 23 is equal to -4x. Divide both sides by -4, so that would be -23/4, or some might prefer to say -5 3/4, right? So that's what that x coordinate would be.